Okay, so on this one, these three equations with three letters, what you got to do is you got to try to get stuff to cancel. So one thing I could do is, let me think, I could take this minus x, and if I multiply it by 2, this whole equation by 2, I can add it to the other two equations and get their x's to go away. Does that make sense? Minus 2x will cancel out this 2x and that 2x, and we'll get rid of x from all the equations. So here we go. So I'm just going to rewrite equation 1 right over here. 2x plus 2y minus 8z is 6. And then I'll take this one here times 2. So it'll be minus 2x. I'm going to make the 2 boom, 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 boom all the way. Minus 2y plus 8z is 8. So add those up, and this is 0. Oh, but that's 0, and that's 0, and that's 14. Now what does that mean when you get a bunch of zeros like that equal 14? 0 equals 14. That's not true. This is no solution. So remember, when all the letters cancel, there's two possibilities. If you get something like 0 equals 14, it's no solution. If you get 0 plus 0 equals 0, that would be infinite solutions, but that is not what we got. We got 0 equals 14, which it does not. So if you get something not true like that, then it's no solution. Okay, so on number 2, let's take this first equation here. Y is less than minus 3x minus 3. So how do we graph it? We start at the number off to the right. So that's down 3. Right there's our first dot at down 3. And then you make this into a fraction, negative 3 over 1. And so that's rise over run. So you go down 3, 1, 2, 3 over 1. There we go. So there's that line. It's a dotted line. So you got to make it a dotted line. Okay, and now for the second line, this one, y greater than x plus 3. So you start at plus 3 right here, at up 3. Get rid of that. And then this is 1 over 1. You have nothing in front of that x. And so this is rise over run. So up 1 over 1, there's the other dot. This one's dotted as well. Because why are they dotted? Because they don't have the equals bar. It should be greater than or equal to make a solid dot. If they have the solid less than or equal, if they have the solid bar, it's a solid line. If they don't, it's a dotted line. Now, where's the shading go? So for the red one, y is less. Shading for the red line is less, is below. This is below that line, right? It's see the y-axis where it goes down to negatives, y less, the lesser y-axis values. Next, we're going to do the, this is y greater. So the purple one we shade above the dotted line, because greater stuff is above. So where do the two shadings overlap? Right here. So that's our final answer, where the two shadings overlap. Okay, so here we have a square root problem. There's nothing in the hook, which really means there's a 2 there. So this is a 2-for-1 deal. So the square root of 64, that's easy. That's just 8. Now what do you do with the other things? Well, so it's 8 out here. Square root of 64 is just 8. And then 4 A's and 36 B's. So remember, it's a 2-for-1 deal. It's a 2-for-1 deal. So, 2 A's in, sends an A out, 2 A's in, sends an A out, and 36 B's in, right? 2 for 1. If you have 36 items and it's 2 for 1, that'd be B to the 18th, right? I just took 36 divided by 2 to get 18. So we have 8, 2 A's, A squared, 18 B's. No more root because there's nothing left in the root. Okay, so here we go now. So we're going to break down the 27. 27 is -3 times -3 times -3. That makes -27. So 3 negatives inside to 3. By the way, there's 3 in the hook here, right? 3 in the hook. So that means it's a 3 for 1 deal. So 3 negatives inside ships 1 -3 out. Now there's still a 3 in the hook there. X's, we got 6 X's. I'll write that out. We got 9 Y's. 2, 3, 4, 5, 6, 7, 8, 9. 9 Y's. So what comes out? Well, again, it's 3 in the hook. It's a 3 for 1 deal. So 3 X's in, sends 1 X out. 3 X's in, sends 1 X out. 3 Y's in, sends 1 Y out. 3 Y's in, 1 Y out. 3 Y's in, 1 Y out. So what comes out? -3, 2 X's, that's X squared, 3 Y's, Y cubed. And that's it. There's no more root because everything left the root. There's nothing left inside the root. Okay, so we have this function, square root of x minus 6. They want us, so I'm going to put it over here, f of x equals square root of x minus 6. They want us to plug in 6, 7, 10, and 15. So if we plug in 6, we get the square root of 6 minus 6, which is the square root of 0, which is 0. If we plug in 7, we get the square root of 7 minus 6, which is the square root of 1, which is 1. If we plug in 10, we get the square root of 10 minus 6, which is the square root of 4, which is 2. And if we plug in 15, square root of 15 minus 6, is the square root of 9, which is 3. So if we put that on a graph, those values, so this is an x, and these guys are y values, right? Function values are y values. So over 6, up 0. 1, 2, 3, 4, 5, 6, up 0. Over 7, up 1. Right there, so over 6, over 7, up 1. Over 10, up 2, 8, 9, 10, up 2. And over 15, 11, 12, 13, 14, 15, up 3. 15, up 3. So the graph is kind of going like that, isn't it? So which of the graphs look like that? Start over to the right and go up kind of slowly like that. It looks like D to me, right? A looks similar, but A looks like it's going too high, too fast. The graph stays low like D does. It's not B because B starts at the origin. That's wrong. It starts over 6, so it's D. All right, so now the 3, and now we're supposed to do fractional powers. Remember what we learned about fractional powers? The denominator swings around into the hook, like that. Okay. Now, let's do the third root. In fact, let's just put the 2 power further out here. It doesn't matter, but I think it's easier to do the root first. So we've got -3 times -3 times -3 squared. Good so far, but 27, I just broke it down. Now, there's a 3 in the hook, so 3 for 1 deal. 3 -3's in, sends 1 -3 out. Squared, right? There's no more root. because these three negative 3's send one negative 3 out and they're gone. Is that making sense there, right? 3 for 1 deal. So one negative 3 comes out of the root, and then squared is 9. So the answer to that is 9. Okay, so number 7, 512 to the minus 5/3 power. How are we going to do it? Well, first off, we got a couple things here. Negative powers, negative makes it go to the bottom. Remember, negative, they're unhappy where they're at. They want to jump to the other side. Then they become positive. See what happened there with the power? The negative powers jump to the other side of the fraction underneath a 1, and then they become positive. So that's the first thing. That's a negative power. Now, what about the fact that it's not only a negative power, it's a fraction? Well, that denominator swings around into the hook. So the third root of 512, and I'm going to put the 5th power out like that. Okay. So now, what are we going to do from there? We got to break down that 512. That's a big number. Divide by 2, and on your calculator, and it's going to be 256. Divide by 2 again. It's going to be 2 times 128. 2 again. 64. That's 8 times 8. Each of those is 3 2's. That's a bunch of 2's. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. 9 2's. Okay, so what does that give us? 1 over, let's make that 1 a little too big there. 1 over the cube root 9 2's. Well, 2, 3, 4, 5, 6, 7, 8, 9 2's to the 5th, okay? Now, he's a 3 in the hook here, isn't he? So that means he's a 3 for 1 shipper. So 3 2's in, 1 2 out, 3 2's in, 1 2 out, 3 2's in, 1 2 out, and they're all gone, no more root. So we have 1 over 2 times 2 times 2, all to the 5th. The 5 is still there. But the root is gone now. The root is gone because everything came out of the root. So this is 1 over 8, right? 2 times 2 is 4 times 2 is 8. 8 to the 5th. So just use your calculator. 8 to the 5th power. It's really, really big. I don't know what it is. Let me see. So 8 to the 5th power. 32768. There it is. Gigantic number. There we go. Okay, so here on number 8, we're supposed to simplify this thing. So remember the rule, powers outside multiply powers inside. Powers outside parentheses multiply powers inside parentheses. So we get x to the 7 halves over x to the 11 halves. See what happened there? The 7 over 1, the half multiplied the 7 over 1, right? The whole number 7 is 7 over 1, so it multiplied. So we get that. Now, powers are going to subtract. Remember that? When the x's are vertical, they're up and down. If the x's are side by side, if it was like this, they would add to be 18 halves. But when they're vertical, they subtract. Where's the bigger one? Who's the bigger power? The one on the bottom. So the answer will end up on the bottom. It's 11 halves minus 7 halves. So that's 4 halves. Nothing but a 1 left on the top because the top disappears. And so this is 1 over x squared. 4 divided by 2 is x squared. Everybody see what happened there? This came from 11 halves minus 7 halves, which is 4 halves, goes there. So the bigger power is on the bottom, so the answer ends up on the bottom. Nothing but a 1 on the top. So it's 1 over x squared. Okay, so here we have a 7th root. 7th root. And so what are we going to do with this thing? Well, the bottom, we're going to need to break down that bottom. The bottom is 2 times 6 divided by 2 in your calculator, 2 times 64. 64 is 8 times 8, and each of those has got 3 2's in it. So we end up with 1, 2, 3, 4, 5, 6, 7 2's. So this ends up being the 7th root. In fact, let's just put that root on the top and the bottom. So we have the 5x on the top, 7th root of 5x. On the bottom, the 7th root of the 128 is what? 7 2's, 3, 4, 5, 6, 7 2's, and y to the 35th. Okay, so how do we deal with this? Well, the 7 in the hook means it's a 7 for 1 deal, 7 shipper. So here's 7 2's, ships out 1 2, and they're all gone. Now what happens with the y to the 35th? Well, if you have 35 items, how many groups of 7 is that? How many groups of 7? Because that's what the 7 in the hook means. He's a 7 shipper. Well, this is 7 times 5, right? 35 is 5 groups of 7. So, right, if you wanted to write it out, I could write out 3, 4, 5, 6, 7 y's. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. See, that's 35 y's, 5 groups of 7. So every group of 7, right, he's a 7 shipper. Every group of 7 ships a y out. Another group of 7 ships a y out. Oh, I forgot a group, huh? 3, 4, 5, 6, 7. There we go. 5 times 7. Every group of 7 y's ships a y out because he's a 7 shipper. So what do we get there on the bottom? We get, what, 5 y's out. 1 from each group of 7. And the 2 that was there as well. The 7th root of 5x just stays on the top. There we go. We got rid of the root from the bottom that way. Okay, so here we have 250, 3rd root of 250. Let's break down the 250. 25 times 10. Anything ending in a 0 is times 10. 25 is 5 times 5. 10 is 2 times 5. So we have now the cube root. It's a 3 in the hook there. Of 5 times 5 times 5 times 2. 3 5's and a 2. So he's a 3 for 1 shipper. So 3 5's in, 1 5 out, and they're gone. So we have 5 cube root of 2. Okay, so we're supposed to simplify this one. Now, right from the beginning, we can actually divide these numbers. So what we're saying is we can go 2 into 250. Why can we divide those? Because they're both in cube roots. They're both in the same world. They're both insiders. So 2 goes into 250 125 times. Just divide in your calculator, 250 divided by 2. And this m cancels one of those, leaving 9 m's. So everything's gone from the bottom. We just have 7 cube root of 125 m to the 9th. So far, so good. There's no more. Look at the bottom is all gone, right? Everything from the bottom divided into the stuff in the top. So there's no more denominator. Now let's break this down. 125. Take your calculator. It's 5 quarters is $1.25. Break down the 25. 5 times 5. And then m to the 9th. So let's write this out. So we have 7 cube root of 5, 5, 5, and m to the 9th. 1, 2, 3. 1, 2, 3. 1, 2, 3. 9 M's. Okay, so he's a 3 in the hook. 3 for 1 shipper. 3 5s in. Ships 1 5 out. 3 M's in. 1 M out. Another 3 M's in. 1 out. 3 M's. 1 out. So what do we got? 7 times 5 times M on the outside. Nothing left in the root. The root vanishes. Nothing left. So that's 35 M to the third power. Okay, so we're supposed to find the distance between these two. Well, the distance formula is the square root. Good thing to put on your 3x5 card for the next test. x1 minus x2 squared plus y1 minus y2 squared. This is x1, y1, x2, y2. So this is the first point's x and y value, the second point's x and y values. So here we go. So this is going to be the square root of x1, negative 3, minus, that's a 3 there, minus x2, which is 2, squared, plus y1, 4, minus, and y2 is negative 2. See the double negative there, the minus from the formula, and y2 is also negative 2 squared. And so what do we get then? We get, what's that, minus 5 squared, and plus, this is going to be 6, right, because the two negatives here make positive. 4 plus 2, 6 squared, so that's 25 plus 36. What is that? 50 squared root of 61. And so there we go.